The air crackles with an almost imperceptible hum, a symphony of unseen forces at play. Beyond the tranquil forests, where ancient trees stand sentinel, lies a realm of colossal machines and intricate processes, a place where nature's raw power is meticulously transformed. This is not just a factory. It is a crucible of industry, a testament to human ingenuity, and a vital artery in the pulsating heart of our modern world. We are about to step through the gates of a high-tech lumber mill, an industrial marvel that shapes the very fabric of our daily lives, often without us ever realizing the profound journey each piece of wood undertakes. Imagine a world where every desk you work at, every chair you sit on, every home that shelters you, begins its life as a towering sentinel in a vast, green expanse. The journey from forest to finished product is a saga of precision, power, and relentless innovation. This isn't the dusty, saw-wielding image of lumberjacks from yesteryear. This is a ballet of lasers, sensors, and robotic arms, orchestrated to extract maximum value from every single log. It's a place where the whisper of the wind through pine needles gives way to the roar of machinery, where the organic chaos of nature is brought into the structured order of production. For most, the journey of wood begins and ends at the hardware store, a neatly packaged commodity. But what truly happens behind those towering walls, amidst the whirring blades and automated systems? What secrets do these industrial giants hold? We are about to pull back the curtain, to venture into the heart of this hidden world, to witness the incredible transformation that turns a raw log into the countless wooden products that underpin our civilization. Prepare to uncover the intricate dance between man, machine, and nature, as we explore the unseen forces that bring the forest into our homes. This is the story of the high-tech lumber mill, a place where the future of construction and design is forged, one precisely cut board at a time. It's a narrative of efficiency, sustainability, and the relentless pursuit of perfection, where every fiber of wood is valued and every process is meticulously engineered. This journey will challenge your perceptions of what a factory can be, revealing a sophisticated ecosystem of technology and natural resources working in harmony. The journey of wood, from towering tree to finished product, is far more intricate and fascinating than most imagine. Consider the sheer scale. A single mature tree can yield enough lumber to build a significant portion of a house, but the process of optimizing that yield is a marvel of modern engineering. Did you know that the earliest forms of lumber mills, dating back to Roman times, were water-powered, using a crankshaft to convert rotary motion into reciprocal motion for a saw blade? These ancient innovations laid the groundwork for an industry that would eventually become a cornerstone of human development, yet they pale in comparison to the precision and efficiency of today's operations. The evolution from those rudimentary water wheels to the laser-guided systems of today represents millennia of human ingenuity focused on harnessing nature's bounty. Modern lumber mills are veritable cathedrals of technology, designed to minimize waste and maximize output. One astonishing fact is the level of scanning and optimization applied to each log. Before a single cut is made, logs are often passed through sophisticated 3D scanners that create a digital model, analyzing its unique shape, curvature, and defects. This data is then fed into powerful algorithms that calculate the optimal cutting pattern to produce the highest value lumber with the least amount of waste. This isn't just about making straight boards. It's about identifying every potential piece of usable wood, from structural beams to smaller pieces for furniture or even wood chips for pulp and paper. It's a digital dissection that ensures no part of the tree goes to waste, a stark contrast to the more rudimentary methods of the past where significant portions might have been discarded. This predictive analysis, often referred to as optimization scanning, can increase the usable yield from a log by as much as 15 to 20% compared to traditional methods, a monumental gain when considering the millions of logs processed annually. The sheer speed at which these mills operate is equally mind-boggling. Logs can be debarked, scanned, and sawn into primary cants, large rectangular blocks, in a matter of seconds, sometimes moving along conveyors at speeds that defy belief. This rapid processing is crucial for efficiency, but it also demands an incredible level of automation and precision. Imagine a laser-guided saw blade, capable of adjusting its angle and depth of cut in milliseconds, responding to the digital blueprint created by the scanners. This dynamic cutting ensures that each board is dimensionally accurate, meeting the stringent standards required for construction and manufacturing. The precision is so fine that cuts can be made with tolerances often less than a millimeter, a level of accuracy that would have been unimaginable even a few decades ago. This relentless pace is maintained throughout the entire facility, a continuous flow of material transformed by an intricate dance of machinery. Beyond the primary cuts, the wood undergoes further transformations. The drying process, for instance, is a critical step that often goes unnoticed but is vital for the stability and longevity of the lumber. Freshly cut wood, known as green lumber, contains a significant amount of moisture. If used in this state, it would shrink, warp, and crack as it dries naturally, compromising structural integrity. Modern kilns, often massive, climate-controlled chambers, carefully reduce the moisture content to specific levels, typically between 6% and 19% depending on the intended use. This controlled drying process can take days or even weeks, but it's a testament to the industry's commitment to quality, ensuring that the wood maintains its shape and strength for decades to come. The science behind kiln drying is complex, involving precise control over temperature, humidity, and airflow to prevent defects like checking, honeycombing, or case hardening, which can severely degrade the wood's quality. Different wood species require different drying schedules, adding another layer of complexity to the process. The evolution of saw blades themselves is another fascinating chapter in the lumber industry story. From the simple hand saws of antiquity to the massive circular saws and band saws of the Industrial Revolution, the technology has continuously advanced. Today, many mills utilize thin-kerf saws, which are designed to remove as little wood as possible during the cut. Kerf refers to the width of the cut made by the saw blade. By minimizing the kerf, more usable lumber can be extracted from each log, further reducing waste and increasing efficiency. These blades are often made from specialized alloys, tipped with carbide or stellite, allowing them to maintain sharpness and durability even when cutting through dense hardwoods at high speeds. The development of these advanced materials and designs has not only improved yield but also significantly reduced energy consumption and maintenance costs, making the entire operation more sustainable. And what about the parts of the log that aren't turned into lumber? This is where the concept of a zero-waste mill truly comes into play. Bark, sawdust, wood chips, and even smaller offcuts are not discarded. Bark can be used as landscaping mulch or as a biofuel to power the mill itself, creating a self-sustaining energy loop. Sawdust and wood chips are valuable commodities, often processed into pulp for paper production, particle board, or oriented strand board, OSB. Some mills even produce wood pellets for heating, turning what was once considered waste into a valuable energy source. This holistic approach to resource utilization is a hallmark of modern lumber manufacturing, showcasing an incredible commitment to sustainability and efficiency. The revenue generated from these byproducts can sometimes account for a significant portion of a mill's overall income, highlighting their economic as well as environmental importance. Consider the global impact. The lumber industry is not just about building homes. It's about providing materials for furniture, flooring, packaging, and countless other products. The demand for wood products is immense and ever-growing, making the efficiency and sustainability of lumber mills more critical than ever. Innovations in engineered wood products, such as glulam, glued laminated timber, and cross-laminated timber, CLT, are pushing the boundaries of what wood can achieve, allowing for the construction of taller, stronger, and more sustainable buildings. These products often use smaller, less valuable pieces of wood, bonding them together with strong adhesives to create large, high-performance structural components, further extending the utility of every tree harvested. CLT, for example, is gaining traction as a viable alternative to concrete and steel in large-scale construction, offering a lighter carbon footprint and faster construction times. The environmental considerations extend beyond waste reduction. Modern lumber mills often operate under strict environmental regulations, including air and water quality controls. Dust collection systems are elaborate, capturing airborne particles to ensure worker safety and prevent environmental release. Water used in some processes is often treated and recycled. Furthermore, the source of the logs themselves is increasingly scrutinized. Certification programs like the Forest Stewardship Council, FSC, or the Sustainable Forestry Initiative, SFI, ensure that timber comes from forests managed in an environmentally appropriate, socially beneficial, and economically viable manner. This commitment to responsible sourcing is a crucial part of the modern lumber industry's ethos, ensuring that forests remain healthy and productive for future generations. The journey of a single log through a high-tech mill is a testament to the incredible blend of natural resource management, advanced engineering, and relentless pursuit of efficiency. It's a world where ancient materials meet cutting-edge technology, ensuring that the forests continue to provide for our needs while striving for a more sustainable future. The sheer complexity and interconnectedness of these processes are a marvel, transforming a simple tree into a myriad of products that are indispensable to our daily lives, all while pushing the boundaries of what is possible in industrial production. The journey of a log through a high-tech lumber mill begins long before it ever reaches the factory gates. It starts in responsibly managed forests, where trees are selectively harvested or clear-cut based on sustainable forestry practices. These practices ensure forest regeneration, biodiversity, and long-term health. Once felled, the logs are transported, often by specialized logging trucks designed to handle immense weights and challenging terrain, to the mill. The logistics involved in moving millions of tons of timber annually are a marvel in themselves, requiring precise planning and coordination. Upon arrival, the first critical step is the reception and sorting area. Here, logs are typically unloaded by massive grapple loaders, capable of lifting multiple tons with ease, and then sorted by species, diameter, and length. This initial sorting is crucial for optimizing the subsequent processing steps, as different sizes and types of wood require different handling and cutting strategies to maximize their value. Large logs might be destined for structural beams, while smaller ones could be processed for pulp or smaller dimension lumber. The logs then enter the debarking stage. This is a vital preparatory step, as bark contains dirt, grit, and other foreign materials that could dull saw blades, contaminate the finished lumber, and interfere with subsequent processing. Debarkers come in various forms, but a common type is the ring debarker, where the log passes through a rotating ring equipped with blunt tools that scrape off the bark without damaging the wood itself. Another method involves drum debarkers, where logs tumble against each other in a large rotating drum, effectively rubbing off the bark. The removed bark is not wasted. It's often collected and used as biomass fuel for the mill's boilers, generating steam and electricity to power the entire facility, or sold for landscaping and other applications, embodying the mill's commitment to resource utilization. After debarking, the logs proceed to the primary breakdown area. This is where the magic of optimization truly begins. Each log is conveyed individually through a series of high-speed 3D scanners. These scanners use multiple laser lines and optical sensors to create a precise digital profile of the log, capturing its exact dimensions, taper, ovality, and any defects like knots, crooks, or rot. This data is instantly fed into sophisticated computer software, which, in milliseconds, calculates the optimal cutting solution to maximize the yield of high-value lumber. The software considers factors such as current market demand for different lumber dimensions, the inherent characteristics of the log, and even potential future market trends. This real-time decision-making process is a cornerstone of modern sawmill efficiency. Based on these calculations, the log is then positioned and fed into the primary breakdown machinery. This typically involves large band saws or circular saws, often arranged in tandem or quad configurations. These saws are guided by the optimization software, making precise cuts to convert the round log into cants, large, rectangular blocks of wood, and side boards. The accuracy here is paramount, often down to fractions of an inch, ensuring minimal waste and consistent product dimensions. Modern mills often use curve sawing technology, where the saws can follow the natural curvature of the log, rather than forcing a straight cut, further increasing yield by reducing straight-line cuts through curved sections and preserving more valuable wood fiber. This advanced technique significantly boosts recovery rates. The cants and sideboards then move to the secondary breakdown area. Here, they are further processed into specific lumber dimensions. Edges and trimmers are the primary machines in this section. Edges remove the rounded edges, wane, from the sideboards, creating straight, rectangular pieces with sharp, clean edges. Trimmers cut the lumber to precise lengths and remove any remaining defects, such as knots, splits, or rot, ensuring that only quality lumber proceeds to the next stage. Again, optical scanners and optimization software play a crucial role, identifying defects and guiding the saws for optimal defect removal and length cutting, often performing multiple cuts simultaneously. This stage is critical for meeting specific grade requirements for various end uses. Once cut to dimension, the green lumber is sorted. Automated sorters, often using vision systems and mechanical arms, categorize boards by species, grade, dimension, and moisture content. This sorting is highly automated and incredibly fast, capable of processing hundreds of boards per minute. These sorted boards are then stacked into precise packages, often with spacers, stickers, between layers to allow for uniform air circulation during drying. These meticulously prepared stacks are then moved into kilns for drying. Kiln drying is a controlled process that removes moisture from the wood, preventing warping, shrinking, and fungal growth. Modern kilns are large, insulated chambers where temperature, humidity, and airflow are meticulously controlled by computer systems. The drying schedule varies depending on the wood species, initial moisture content, and desired final moisture content, typically taking several days to weeks. This precise control is essential to prevent drying defects and to achieve the optimal moisture content for the lumber's intended use, which significantly enhances the stability, strength, and workability of the lumber. Energy efficiency in kilns is also a major focus, with many mills utilizing waste heat or biomass fuel to power them. After drying, the lumber undergoes a final grading and finishing stage. Planers smooth the rough surfaces of the dried lumber, creating a uniform, finished product that is ready for construction or further manufacturing. Further visual or automated grading, often using sophisticated camera systems, ensures that each piece meets specific quality standards, categorizing it for different applications, e.g., structural framing, finish lumber, or appearance grade. Any remaining defects might be trimmed, or the lumber might be finger jointed to create longer, defect-free pieces from shorter ones, maximizing resource utilization. This final grading ensures that customers receive products that meet their exact specifications. Finally, the finished lumber is packaged. This involves strapping bundles of boards together, often wrapped in protective coverings to shield them from moisture, UV damage, and physical abrasion during transit. Robotics and automated stacking systems are commonly used here to efficiently prepare the lumber for shipment, creating stable and secure bundles. The packaged lumber is then moved to the shipping yard, ready to be loaded onto trucks, trains, or ships, embarking on its journey to construction sites, furniture manufacturers, and retailers around the globe. Throughout this entire process, rigorous quality control checks are performed at various stages, from initial log inspection to final product grading, ensuring that only the highest quality lumber leaves the factory. Safety protocols are also paramount, with extensive training, automated safety systems, emergency stop mechanisms, and personal protective equipment protecting workers in this high-speed, heavy machinery environment, making it one of the safest industrial settings despite its inherent dangers. The journey we've just witnessed, from towering tree to precisely cut lumber, is a testament to human ingenuity and the relentless pursuit of efficiency. It's a world where ancient materials meet cutting-edge technology, transforming raw nature into the very foundations of our modern lives. But what if I told you that the innovations in wood processing are only just beginning? We've seen how a high-tech lumber mill optimizes every fiber of a tree, turning what was once waste into valuable resources. But the future holds even more astonishing possibilities. Imagine wood that can conduct electricity, or transparent wood that could replace glass and windows, offering superior insulation. What about self-healing timber, or wood-based materials that are stronger than steel yet lighter? These aren't concepts from science fiction. They are active areas of research and development, promising to revolutionize construction and design in ways we can barely comprehend. The potential for wood to become an even more versatile and high-performance material is immense, driven by advancements in nanotechnology and material science. If you found the hidden world of the lumber mill captivating, then you won't want to miss our next deep dive into another industrial marvel. A new video just appeared on your screen, exploring the incredible processes behind the manufacturing of advanced composite materials. Click on it now to continue your journey into the unseen engines of our world. Don't forget to subscribe to our channel to unlock more stories from the factories that build our future, and hit the notification bell so you never miss an episode. We love hearing from you, so tell us in the comments below, what was the most surprising fact you learned about lumber mills today? Was it the 3D scanning, the zero-waste approach, or perhaps the sheer speed and precision of the process? Share your thoughts and join the conversation. Your insights help us understand what truly fascinates you about the world of industrial production.